General Physics 1 is brought to you by Physics Classroom. Hello everyone. Let's continue with part 2 of lesson 3, calculating the magnitude and direction of a resultant vector. To determine the resultant vector of two or more vectors in any direction, one of the ways is the component method. Let's take the preceding problem as a sample to show how it will be done. Find the resultant of the following vectors. 10 kilometers north, 25 kilometers 30 degrees north of east, 30 kilometers 60 degrees north of west. For the solution, the resultant vector in the sample problem can be found by using the graphical method, but it can also be solved using the component method. Here's how it should be done. 1. Find the x and y components of each vector using trigonometric functions. This process is called vector resolution. 2. Find the sum of the x components and the sum of the y components. 3. Use the Pythagorean formula to determine the magnitude of the resultant vector. 4. Use the tangent function to find the direction of the vector. To draw the given vectors, we have to use the scale. 1 unit is to 5 kilometers. To solve the magnitude of the resultant vector, we used the Pythagorean formula. And to determine the direction of the resultant vector, we used the tangent function. Let us figure out the solution to the previously given example by drawing the given vectors again. This is the Cartesian plane, where the three given vectors must be drawn. The first vector must be drawn from the center of the Cartesian plane, which is the point of origin. In this table, each of the given vectors shall be resolved into its horizontal and vertical components. This process is known as vector resolution. The first vector is drawn from the center of origin. Its magnitude is 10 kilometers, whose direction is directly to the north. And now let us resolve 10 kilometers northward to its horizontal component. Since in the given vector, there is no horizontal displacement, then the horizontal component of the given vector is 0. The given vector, 10 kilometers northward, obviously, shows a vertical displacement, so its vertical component is likewise 10 kilometers north. Then, the second vector is drawn from the tip of the first vector. The second vector has a magnitude of 25 kilometers, and its direction is 30 degrees north of east. The given vector, 25 kilometers 30 degrees north of east, can be resolved into its horizontal component. How? Draw the given vector again, then draw a horizontal line eastward, 30 degrees from the given vector. Drawing a vertical line, notice that a right triangle is formed. The horizontal line eastward represents the horizontal component of the given vector. This horizontal component is denoted by d sub x. d sub x is equal to d times cosine theta, where d is 25 kilometers and theta is 30 degrees. Substituting the given values to the formula, we get 21.65 kilometers east. Let's determine the vertical component by drawing the given vector, 25 kilometers, 30 degrees, north of east. Draw a horizontal line 30 degrees form the given vector, then a vertical line, representing its vertical component. This vertical component is denoted by d sub y. d sub y is equal to d times sine theta, where d is 25 kilometers, and theta is 30 degrees. Substituting the given values to the formula, we get 12.5 kilometers north. To finalize the vector representations, the third vector is drawn from the tip of the second vector. The third vector has a magnitude of 30 kilometers, and its direction is 60 degrees north of west. To resolve the given vector to its horizontal component, again, we have to draw the given vector with 30 kilometers magnitude, 60 degrees north of west. Then draw a horizontal line which represents the horizontal component. As previously discussed, this horizontal component is denoted by d sub x. d sub x is equal to d times cosine theta, where d is 30 kilometers, and theta is 60 degrees. Substituting the given values to the formula, we get 15.00 kilometers west. And for the vertical component denoted by d sub y, we have to draw again the given vector. The same formula is applied. Again, this vertical component is denoted by d sub y. d sub y is equal to d times sine theta, where d is 30 kilometers, and theta is 60 degrees. Substituting the given values to the formula, we get 25.98 kilometers north. Now that we have already completed the vector resolution, let's have the summation of the horizontal components d sub x, and also the summation of the vertical component d sub y. Let us rewrite the values we obtained from the vector resolution we made. Let us replace the direction of vectors by positive or negative sign. Going to the east is positive, so 21.65 east will become positive 21.65. Going to the north is also positive, so 12.5 north will become positive 12.5. And then, for the third vector, the horizontal component is going to the west. This is negative, so 15.00 west will become negative 15.00. And finally, for the vertical component of the third vector, this is going to the north again, and this can be written as positive 25.98. Thus, the sum of the horizontal components is 6.65 kilometers east, and the sum of the vertical components is 48.48 kilometers north. Let us then draw the resultant of the given vectors and solve for its magnitude and direction. Solve for the magnitude of the resultant vector. From the vector resolution that we made, we have summation of d sub x equals 6.65 kilometers east, and summation of d sub y equals 48.48 kilometers north. We use the Pythagorean formula to determine the magnitude of the resultant vector. The resultant r is equal to the square root of the summation of d sub x squared plus the summation of d sub y squared. Substituting the values 6.65 kilometers to d sub x and 48.48 kilometers to d sub y, we then get the magnitude of the resultant vector equal to 48.93 kilometers. After getting the magnitude of the resultant vector, let us now determine the direction of the resultant vector. We have to solve for the magnitude of angle theta to completely express the direction of the resultant vector. To do this, we may utilize the formula from the definition of the tangent function of angle theta, that tangent theta equals the side opposite angle theta, d sub y, over the side adjacent to angle theta, d sub x. Likewise, angle theta equals arctangent d sub y, over d sub x. Substituting the given values to d sub y and d sub x, we get the magnitude of angle theta equal to 82.19 degrees. Thus, the resultant vector r is equal to 48.93 kilometers, 82.19 degrees, north of east. Learning is by doing. Solve the given problems by applying what you've learned. Solve the problems below. Number 1. Use the component method to find the resultant displacement of the dog, searching for a bone. The dog heads for 65 degrees, north of west for 8 meters, then it turns, and heads west, for 6 meters. Number 2. How fast must a car travel to stay directly beneath an airplane that is moving at 115 km per hour, at an angle of 32 degrees to the ground? Isla left the school at noon to go jogging. She ran 3 kilometers south, 5 kilometers east, 2 kilometers south, and finally, 4 kilometers west. Determine the resultant vector by component method.